Hey guys, this next video for you is about the rules for exponents. And we're getting into this concept of exponential functions, and things that we need to know about exponential functions are how they can operate. Something that might have already come up for you is if you're doing the geometric sequences, writing them as exponential functions, that little workspace, that they showed you this, show the step-by-steps to rewrite what you came up with for the formula for a geometric sequence in an exponential function structure. Well, that's really where we're headed. In order to do that, there are some basic rules that we have to understand about exponents. Exponents follow this idea. They're basically repeated addition. So if I take, for example, 5, right? And if I have one single solitary 5 written down, try it again, okay? Worst 5 ever, but whatever. If I have a single 5 written down, then it technically has an exponent of 1. We don't have to write the 1. I would encourage you not to. But you should know that just because we see a single 5 on the screen, that's a 1. If we put a 2 up here, what that's telling us is that we really want to take 5 and multiply it by itself. The 2 for the exponent means there are those two 5s. So a 3, a cube. I can get my board to work the way I want it to. Worst 5s ever, but the fact that there is a 3 exponent right here means that there are 1, 2, 3 5s in a row, right? Little review. What about 5 to the negative 1? If I can write a negative 1. What does that mean? How do you have a negative exponent of anything? Well, let's actually talk about that like this one. If we think about 5 to the third as in 1, 2, 3 5s in a row, and we think about 5 squared as in there are 2 5s, this 1 still means that we have a single 5 in our problem. But the negative, that's the problem. The negative, I'm going to give you the answer and then we'll work our way backwards, means that we write a 1 and we put 5 to the 1 on the bottom. The negative literally does this step right there. That's what the negative does. It makes the fraction flip. So if we continue writing 5 to the negative 2, 1 over, because of the negative, 5 squared, which would mean that on the bottom of this is 5 times 5. All right. Continuing on, what we can do with some of these rules. 5 to the negative 3, which would be 1 over 5 times 5 times 5. That's not a 5. But that is. You get your calculator out, you realize 5 times 5 times 5 is 125. So whether you have a positive exponent or a negative exponent, that tells us how many times we're going to repeatedly multiply out. I guess the negative tells us how many times we're going to repeatedly divide out. Let's finish it off with 2 things in this video. There are other rules, but here we go. 2 more things out of this one little quick snip at what you need to know. In that, what about 5 to the 0? Well, 5 to the 0, like anything to the 0, actually is going to be consistently the same answer. It's this. But why is it 1? So think about it in terms of a pattern. We'll have some other ways to think about it in some of the next videos you're going to have the chance to watch, if you want to watch them. 5 to the third. Let's start with 5 to the third. As in, that is 3 5s all in a row. Then 5 squared must be 2 5s. 5 to the first must be 1 5 every single time. It's kind of like we're getting rid. Somehow we are saying, take one away, take one away, take one away. But that takeaway process is really a division process. We're dividing by 5 every time we go down. So if I want to go to 5 to the 0, I'm taking this 5 amount, dividing by 5, going from 1 to 0. This would be saying, I'm going to take the where I was, and if I'm multiplying up by 5s, I'm going in reverse, divide by 5. So I'm going to continue dividing by 5, and we get the answer of 1. That works all the time for us with anything to the 0 power. Stick around for part 2. I got some actual combinations I want to share with you. Thanks for watching this video.